Hey folks, welcome to the video. Today we're going to take a look at how you can use PowerShell to help diagnose network latency issues. To do that, we're going to send ping requests to multiple IP addresses and record the round trip times. We'll then take a look at how you can parse these results to help determine where and when you may be experiencing some latency. The original concept for this script came from when I was working for a company who had multiple remote offices. One of these offices just kept experiencing network latency, network drops, seeming at random intervals. So to help to figure this out, I wrote this script that would ping each IP address along the route between the office and the remote resources that they were trying to access. I then analyzed that data and was able to find out exactly what was going on. Be sure to stick around at the end of this video to hear the crazy story about what the actual cause of the problem was. This video is the second in a series in monitoring your network with PowerShell. If you didn't watch the first video, don't worry. These are all self-contained. I will still explain everything you need to know, but please do go back afterwards and give it a watch. But for a brief overview, we used a .NET object to send ping requests to multiple IP addresses every minute. If there was a change in status from successful to timed out, we would record those results to a CSV file. We then took that CSV file and calculated the duration of downtime over a given period. And the reason we only wrote the changes is that over a 24-hour period, each IP address would produce 86,400 records. Across 3 IP addresses, that's over 250,000 records a day. Way too many to just have sitting around as some CSV files. In this video, we are going to need more details so we can see not only what our downtime is, but also what our latency is. So to determine that latency, we need to keep detailed records. So we're going to use SQLite to hold the data this time. We'll then see how we can parse through these hundreds of thousands of records quickly and easily in PowerShell and see how you can identify any potential issues that you may be having in your network. So without further ado, let's get automating. To get started, the first thing that you'll need to do is install the mySQLite module. It's a community module made by Jeff Hicks. It worked really well for everything that I've ever needed to use with SQLite. No additional files or anything are required for installation. The module contains everything that you need. Once you get that installed and imported, you should be good to go for the rest of this video. So revisiting what we did last time, where we used the system.net network information to ping an IP address, we'll go ahead and rebuild that same functionality here again. And remember, we're doing an asynchronous ping so that we can have it run independent of PowerShell, so it's not going to stop our script and wait for the results to come through. We can run multiples at a single time doing this. But just ping an IP address real quick. We see that we got our response, round trip time, and everything comes back. And we even saw how we could add timeouts to those so that we can ensure that we're going to get our returns in the amount of time that we expect them to get there. So what we want to do now is take these results and then write them into a SQLite database. So the first step in this process is going to be to actually create our database file. All right, so just call this one pingtest.sqlite, and we can go ahead and we can run that, and that will create our file. So see here that it's been created. Now, one of the things that you need to take into consideration is if your file is already created, right? Do we want to override it? Do we want to ignore it? All those things like that. You see, we'll keep getting an error message if we rerun that. We can do a -force to overwrite the file, but then you're going to lose all of your data doing that. So an easy way to prevent that from happening is by just creating a quick test path function. So we come here and say if test path db does not exist, right, go ahead and create the SQLdb file. Otherwise, just continue on with our script. Now the next thing that we need to do is we actually need to build out our tables. So if we look at the module itself, there is a new mySQLite db table function, and we can find some examples out there on exactly how we can build these out. So you can see you can build an ordered hash table where you can define what your different fields are and the data type of those fields. Right, so in this case, we're going to define our columns, and we're going to start with a date time column to record when it happened. Now, SQLite itself does not have a datetime object, so it has to be a text object. Then the address that we are checking, the round trip time, which in this case is going to be an integer, and then we'll go ahead and we can record our status as well. We build all these out into an ordered hash table, and then we can pass that into the mySQLite DB table along with your file path and your table name. So in this case, I'm going to name the table after the address that we are attempting to hit. Run this again. So we had an error. This is actually a SQL logic syntax error. The reason behind this is because SQLite does not support having period, full stop inside of your table name. It also doesn't support having tables that start with a number. They have to actually start with a letter. What we can do is just write a quick little function in here to go ahead, and we'll just tack on host underscore to the front and then replace any periods with underscores. And now we've created our first table. Right? Similar to the creating of the database, though, if I run this again, it's going to start throwing out errors if it override or things like that. So you can actually build in some additional functionality as well to determine whether or not you actually want to go ahead and attempt to create the table again. So what we can do is use the get mySQLite tables, which will return all the tables in that particular database file. And then we can check and say, hey, if this table name is not contained within inside of this, the results here, then go ahead and create that. Right, so now we have a foolproof. I can sit here and I can run this over and over and over again. I'm not going to overwrite any data. I'm not going to add anything additional that I don't want to add into there. We can take this even one step further and actually turn this into a function. All right, so first function is going to be a new address table. So it's going to have predefined what our columns are going to be, the way that we're going to create the table name. That way, every single time that we do it, we end up with the same exact table name and functions and columns and everything. All right, and then what we can do here at the end is we can output the results. All right, so a nice, quick, and simple function, just wrapping the exact PowerShell that we were just using. So now I can call this again over and over and over again as many times as I want with whatever address and whatever database file I want. And I can ensure that my table is going to use the same naming convention, same columns, same everything. So last time we used a timeout because we wanted all of our processes to run in under 1 second. This time we don't want to force a timeout because we actually want to know what our latency is. So we can stick with the 5-second default timeout that it exists on there. You can actually increase that to a longer interval if you want, but in this case, we're going to go ahead and we're going to run on 5-second intervals. So let's take a look about how we can get that data into our database. All right, so we'll go ahead and run our ping again, where we're going to use our network information .ping, do our asynchronous ping out to our address, and then get the results back. So again, we had a successful ping, less than a millisecond, so we know that it was good. Now, as I mentioned, we want to now insert that data into our SQLite database. We can build out a query string to be able to do this. We can build out a query string to do this, and then use an insert command. So invoke mySQLite query, put the path again to our database file, and then we're going to build out our query. So insert into our address table that we defined here earlier, our date, time, address, round trip, and status columns, and then we build out the values based upon that. Right? So we're going to get our date, our address, our reply round trip time, and our reply status. Now we need to define our date. As I mentioned earlier, MySQL does not support dates, so they actually have to be strings. But what we can do is we can easily translate our date into a string that can then be reinterpreted by PowerShell later on. Right, so we're going to go ahead and get date. We're going to switch it to universal time, which is just something That's, kind of a good practice to do. That way, if you're running it from multiple different machines and different areas and things like that, you're always going to know exactly what the time was. All right, and then we're going to do a toString U. Right, and that sets it to the ISO 8601 format. Here's what our string will look like. So it'll be the same every time, and that is a string format that .NET and by extension PowerShell can read without any problems. Now, building out a query string like this is typically not something that you would want to do in a setting where you're going to have data, from unknown sources coming in. Right? And that's when you're talking about writing into, SQL, the old Bobby drop tables, right? This is where those things come from. When you're just using a SQLite database in a script that, only you are going to be using, it's not that big of a deal. But we can go ahead and we can run this now, insert our data, and then we can do an invoke a SQL query and run a select to be able to get that data back. So in a later video, we can revisit this and use an actual SQL Server or SQL Express, and we can see how we can do parameter passing and data sanitization and all of those type of things prior to running the queries. But as I mentioned, in this case, we're just using a localized script that's not going to be accepting data from outside of itself. So in this situation, we're good to go. Like last time, we're going to just create a while loop to go ahead and run it for a predetermined amount of time. Right, so in this situation, we're just going to go ahead and we're going to run it for 60 minutes. Right, so we're going to create a timer object using the stopwatch. We're going to tell it while the timer elapsed, total minutes is less than what our run minutes are defined as, which we have set to 60, to keep running this over and over again. Right, so we can kick this off and it will continue to run over and over and over again. But as I mentioned, there is no timeout on this. So if it takes, less than 5 seconds to run, it's going to keep running, every millisecond, right? You're going to get tons and tons of data. So what we're actually going to do, this is similar to what we did last time as well, is we're going to put a run timer in here. So this is going to be a second stopwatch object, which is running independently of the first one. And then we're going to put this at the bottom of our run. So after we start our process, right, we're going to come in here, we're going to say, we're going to give our runtime, we're going to start it right here. Then we're going to do our ping. Then we're going to insert it into our database. And then we're going to say, while our runtime is seconds is less than 5, we're going to go ahead and we're just going to pause the script at this point. All right, so if it takes longer than 5 seconds for all this to run, it's just going to go right into the next while loop. Right? If it takes less than 5 seconds, it's going to break here and it's going to wait to run again after the next 5 minutes. So we can run this through. Obviously, you're not going to see any outputs or anything coming from it, but after a few seconds, we should start seeing some data start to populate. I went ahead and killed it, and then we can take a look at our table now, and we see that we're starting to get multiple results back in from each time that we ran. So how do we take this and then do it against multiple IP addresses? I'm going to actually open up a new window here, and we'll take a look at exactly how we'll do that. All right, so I'm going to define 3 IP addresses here. I'm trying to find latency between my computer and a remote server that I have. Right, so what I'm going to do, I'm going to ping my local gateway, I'm going to ping the remote gateway, and then I'm going to ping the remote server. All right, and then that will tell me where in the line I'm having latency issues. So what we actually want to do is we want to run these in parallel with each other. The problem that we're going to face is that we've defined custom functions in here. And those functions are not easily passed into a for each parallel loop. They can be. It's not pretty. It's typically not something that I would recommend. So what we're going to do is we're going to take our test IP addresses that we just defined up above, put those into a for each, a non-parallel for each, so that we can take that data and build out a custom object. All right, so we're calling our function here. We're passing our database path, our address, and then what we're going to do is we're going to record the address and the table name together into one object. This is so I don't have to define that address type multiple times. So that naming convention that I'm using, I don't have to pass that into a for each parallel where it can't read it. There's all sorts of practices around not wanting to do that. So we go ahead and we set our IP addresses, and then we're going to run them through this for each, which is going to create this object here. Now we have our address and our table. So now we can use that test objects, and we can pass that into a for each parallel, which will then allow us to call our functionality over and over and over again. So we can take our original statement from over here and just paste it into our for each in here. So we're going to need to redefine. It's now going to be underscore address, and then this will be underscore dot table. Right, this maps in from here to here, and again underscore dot address. Now the one thing to consider when building this out is our run times and the creation of the for each parallel. So I could very well have put this while loop on the outside and done the for each parallel inside of it. However, the way that the for each parallel works is it actually creates a separate run space for each time that it is invoked. So what this would actually end up doing is causing the parallel to recreate itself every single time that we were running a new object, right? And then it would also cause, if one of them slowed down, it would cause all of them to slow down because you're waiting for the completion of all the parallels before you're instigating the new parallel. So to prevent that, we do the parallel once, and we're essentially invoking this 3 separate times, right? In 3 separate run spaces. This is going to continually run for an hour. We're going to move our run minutes out of there. Right, so this can be something that we can be defined. And again, since it is defined outside of the parallel loop, we need to add in the using run minutes. So if we go back to our original script here, all right, we can take our function and our SQL table creation, and we can paste those in here. Then we can even go a step further, making this truly a script and define some parameters. So we'll define the string array outside of the script, right, and then define a database folder. Let me go ahead and move these out. Right, so our database folder we'll use to build out our database path. All right, so on the first go around, right, we just set that our database path was going to be pingtest.SQLite. But if this is something that you want to potentially run across multiple different systems and servers, right, we can go ahead and we can use some better naming conventions. In this case, what we'll do is use the environmental variable of the local computer's name and use that to run it across so that you'll know exactly where this ran from and where it was running to when you're looking at your data later on. All right, so we're going to define our database folder here, and we're going to join in the system name.SQLite, which is going to become the name of the database file. Right, so if we run this again here like that, it will generate our new file. Now I could expand this to include additional checks for setting the folder or setting a default path to PS script roots. Those are all great things to do, kind of outside the topic of this particular conversation, but is definitely things that you would want to consider when building out a fully fledged automation. We'll go ahead and save this. Also want to go ahead and include our run minutes as a parameter to pass in as well. So now we have our script saved. We can go ahead and open up any PowerShell window and run it. So I'm gonna go ahead and create our IP addresses again, and then we'll call our script. So the invoke ping latency test PS1, the IP addresses are obviously going to be the array of IP addresses that we created. Database folder is where we want to save the file at, and then our number of run minutes is defined. And we'll let this run for a little while in the background, and in a few minutes we should have some good data to test with. Now let's go ahead and take a look at some of our data that we got back. So I'm going to just take a look at one of the IP addresses that we were pinging and see what type of results that we have back. So again, the invoke mySQLite query to our database path, select star from the table, and then get our results. So you can see we got quite a bit of good results. You do see some, ups and downs in here, which is good. It gives us some data to take a look at. So now that we have our results, let's take a look at what we can do with them. All right, one of the things that we can do is we can actually come in here, we can do a measure object, property of round trip time, and then ask for the average. So it's going to give us our average round trip time. So we see that 84 seconds, right? Now, one of the things that you need to be cognizant of, though, is that if you have a timeout, your round trip time is actually going to be 0. And that can greatly affect your averages, right? So we can go ahead and throw a where object status equals success, and then get our average. Again, it's the same because we didn't have any failures in there, but we can definitely get that data back. The other thing that we can do is we can take a look at our different date time objects. Right, so we can do results where object date time is greater than a particular time. And PowerShell is typically smart enough, as we mentioned, this is a string value, right, but it is smart enough to be able to interpret some of that. It's not guaranteed that it'll work. Right, so if I, for example, come in here and I say, give me the date time greater than 7:14, right? I got a pretty good mixture of results back in there. Right? What if I want to get all the ones where the date equals 7:14? So I want everything from this day 7:14, no matter what time it was during that day. Right? If I tell it that, nothing comes back, because it doesn't recognize this as a date time, right? Because on an actual date time, you would have a .date, which would give you just the date without the time attached to it, which would work. In this case, you're going to get back nothing because these are actually string values. If we look at the member objects on here, we can confirm that. Right, so we see that our date time is a string. So how do we go about actually working with the date times in there? Well, what we can do is we can convert this date time string into an actual date time simply by passing it to the get date commandlet. And so what we'll do is we'll do a for each through our results, and we'll set date time equal to get date time. Since we built that string in a way that is easily recognized by PowerShell, we don't need to do anything else. We pass this through here. We now take a look at our date time property, and we see that it actually is a date time object. So if we go here and we run the equals to the 7:14, boom, you see now you have all your requests from 7:14, no matter what time of day they ran. So this is pretty great. This is pretty interesting, but again, I kind of hard coded a table name into here. What we want to do is we want to actually take a look at all of our tables. I want to know, I was pinging multiple IP addresses. How can I get the data back from all of those? Well, again, just like we did earlier with the check, we can use the get mySQLite table to return back all of our tables. You'll notice that there is one in there called metadata. All right, so there could be, that's just a default table that exists inside of all SQLite databases. So that's something we need to account for. So what we'll do is we'll build out for each here, and we're going to take our tables.names where our object matches hostname underscore. All right, so if our name of our table starts with host underscore, then we'll go ahead and we'll run our query and get our data back. Actually, there should be a caret here, so that is the beginning of the string, so that if there was some other random table that happened to have host underscore somewhere else in there, it would not get picked up by this. If we run this, we can see that it gave us data back from each one of the addresses that we were pinging. All right, then we can go ahead and we can save this to a variable as well. And now, just like we did before, just go ahead and convert all of those results, the datetime string, back into an actual datetime object. That way, no matter what we want to do later on, we don't need to worry about how that's going to look and how that'll be affected. So now we want to take a look at how can we compare this data? Like how is this useful to me? All right. And we can take a look at it using the group object commandlet. So the group object will take your all of your results and then group them based upon whichever property you define. Right? So if we say address, we see here that we have 120 from each one, and you can see each entry that matches that particular address. Now, another way that we could look at it is if we wanted to look at it on a minute by minute interval. And the way that we can do that is by actually passing a property to the group object, which will be evaluated. So if we can take our date time, and we're going to turn it back into a string, but here I'm going to define my string of four-digit year, 2-digit month, 2-digit day, 24-hour time, and then our minutes. Right. So what this is actually going to do is just going to define each one of our minutes. Right. If I had come in here and I just said date, time, minute, for every hour that would be repeated. Right. For every day that would be repeated. That wouldn't be proper grouping. But we have our 1 minute intervals defined in here so that we can see that. Now what we can do is we can parse through each group. Right, so if we do a for each object and we get our group, you'll be able to see the results from each grouping. Right? It's kind of blocked out. I'll just throw a cheap little string output in there, but you see how these are getting now grouped and broken apart based upon the minute intervals. And it contains all of the IP addresses inside of them. Well, from here, we can use a little grouping inception, right, where we can group the group. Right, so now we can group our group on properties of address. Right, so I'm saying that for every minute, group all of the results together, and then for within that minute, I want you to group together the entries from each particular IP address. And what that will look like here is, again, not much that you can see. We now have our groupings by our date and our time and things like that, but it's not really showing us much. So we're actually going to take that a little further down, and we can get the averages from each of these groupings. All right, so we'll take each address, we'll take the group from within that group, where object status equals success, and then measure our round trip times. So now we have each round trip time for each address for each minute. I know it Probably sounds rather confusing, but if you break it apart like this, you have each minute, then each address within that minute. What we can do from here is we can actually output our results, because this doesn't tell me anything. This counts average. I don't even know what address that goes to. All right, so let's build out a little functionality in here to be able to do that. What I'm going to do is I'm going to create a hash table, and I'm going to set our date time in there to name. Name is actually the group object property that gets created. All right, so whatever you grouped on is going to be called name. And I can then take that, and what I'm going to do is set my average time here. I'm going to get that as an output, and then I'm going to add an entry into the hash table for each address. So in this case, name maps to the address property, and then I'm getting the average out here. And at the very end of this, we can cast that hash table as a PowerShell custom object, which is something that you're familiar with. You'll see the output here. So when we run all this together, we now see that we have, for each minute, each address becomes its own column in here, and then we can see our run times, what our round trip times are. So we can see here, this is where we had some latency. This address is staying pretty steady, this first one here. So there's definitely something between these two addresses that is causing my latency in the issues that we're seeing. My apologies for an abrupt jump cut here, but as I was going through and editing this video, I thought of a better way to show how this group object and these for eaches are all working together. What I'm actually going to do is I'm going to kick them off inside of the debugger, and we'll be able to see step by step exactly how this is going through. So we have our first group here, which is represented by our underscore, which has a collection of 30 objects in it. And you can see each one of those objects falls into this 0 minute of the hour, and what our name is, right? So what that time period is. What we're going to do is we're going to go ahead and set that into the hash table. Our hash table now has one value with the date time in it. And then we're going to group the group on the address. So if we look here at the initial group, you see the 3 different addresses listed down in here. So what we want to do is we want to go through each one of those inside of that collection. So if I get those and then I run a measure on them, we can now see that we have our average for this IP address. And then I'm going to add that specific IP address and its average into our hash table. All right, and then we simply repeat that for each IP and its average. So as we go down, we see each one getting calculated and each one getting added into the table. And then once we've gone through all of them, we just output it as a custom object. All right, which then brings us back to the next minute, right? So now we're at 11:01, where previously we were at 11 on the dot. And we're going to recreate the hash table again. So now we just have the date time in there. And then it becomes the same thing over and over again, where we add in each individual IP address and the average from that IP address in that time frame. So I hope that makes things a little bit clearer for you going forward for the rest of this video. So that worked great when I had a small set of objects. I ran this for all 10 minutes here, and I could see some latency showing up on this particular server, and I was able to pinpoint it to that. What if I had it run for a day? That's going to give me a whole lot more data back. All right, but you see we got lots of data. I'm seeing some spikes in here. It's kind of hard to tell though where they're coming and what they want to look like. So what we can actually do, as I mentioned here, build a custom date time. All right, so let's say I want to group it by a 10-minute interval. All right, if I were to come in here and just remove this first M, well, what that's going to do is that's actually going to cause this to say that 1 would also be 1 instead of 0, 1. All right, we don't want to do that. So what we're actually going to do is put a substring onto this. So we'll say substring starting at 0 and going to 15. We're going to get that. And what that's going to do is that's going to chop off that last digit. Right? This is a 16 character string. So we're just chopping off the last character, which is going to give us all of our averages in a 10-minute interval. Right now I can see that when I'm having spikes, they're lasting less than 10 minutes. Makes it pretty easy to spot. And then I can even come in here and I can sort my results. And I sort object on that one IP address that is having problems. I can see here's all my high times. Oh, they're all happening at the top of the hour. All the other hour or 10-minute intervals, are pretty steady. But at the top of the hour, I'm getting these results back. So this shows you how you can use different techniques, different ways to be able to not only gather all this data, but then go through and be able to use it to find where your slowdowns are, right? If I could see if this happened to jump up at the same time, I would know, okay, well, my issue is between that address and the other one, right? So it could be remote gateway. In this case, it seems to be isolated to that particular server. I can go through and I can troubleshoot and determine exactly what is causing that latency there. So I hope this is something that you can take and use inside of your own environments to be able to troubleshoot any particular issues that you may be having as well. As promised, the crazy conclusion that this script helped me find, we had a remote office, and when I say remote, I mean remote, like middle of nowhere, Texas. Just randomly throughout the day, there would be network drops, slowdowns, etc. This script helped me determine the network issues were happening at fairly regular times, but there were a few outliers here and there. But the intervals were always different. It was just, there were some patterns, but there wasn't other ones. Knowing when they were happening, though, I was able to take a look at the rest of the traffic, but I couldn't find any spikes or other usage that would result in the issues that I was seeing. Eventually, I traveled out to that office to personally check and test each and every computer and network device out there. I was there all morning, and of course, not a single issue happens. As I'm getting ready to go grab some lunch, a freight train comes rolling down the tracks right in front of the office at like a snail's pace. If you've ever been to rural Texas, you know that these trains can be long. So I flipped open my laptop to answer a few emails, and boom, the network's down. I run all around the office, testing every piece of equipment, every computer, everything comes back fine. It is simply the line from the building out to, wherever the ISP was taking it. So I give the ISP a call. They tell me that the DMARC shows us up, so it must be something inside of my building that is causing this issue. As I'm going through, checking some more things, suddenly the network comes back up like nothing has happened. Basically, every time the train would roll by, it was just enough pressure to do something to the cable to cause the connection to either break or to get really weak. A week later, they came out and reran the lines under the tracks, this time encasing it inside of a steel tube, and the network was perfect after that. So it's just a fun little story that I thought you would enjoy, showing you how PowerShell helped me solve a real-world issue like that. I hope you enjoyed the story and the rest of the video as well. If you did, please give a like and subscribe. If you have any questions or suggestions for future topics, please leave a comment below. Thank you all for watching, and I'll talk to you again in my next video. Thank you.